Exercise 15. Using a Johnson moments distribution. In mathematics, a moment is a specific quantitative measure of the shape of a function. It is used in both mechanics and statistics. If the function is a probability distribution, then the zeroth moment is the total probability, that is 1. The first moment is the mean. The second central moment is the variance. The third standardized moment is the skewness, and the fourth standardized moment is the kurtosis. The mathematical concept is closely related to the concept of moments in physics. At risk comes with 3 Johnson distributions. 2 of them are designed for bounded and unbounded parameters. We will not use these. At risk contains a third distribution that uses these 4 moments as parameters to build a certain distribution. It is called a Johnson moments. In other words, if you can calculate out of a certain data set these 4 moments, the mean, the standard deviation, the skewness, and the kurtosis, you could construct a distribution function that exactly mimics these 4 moments or parameters using the Johnson moments distribution. We will use here the theoretical parameters calculated from the previous compound distribution. On range B136 through B139, we will insert the theoretical statistics for these 4 moments. On cell B136, click on the Insert Function button of At-Risks ribbon. Then, select Statistic Functions, Theoretical, to retrieve all the theoretical statistics that can be calculated with these functions of any particular at-risk distribution. Select Risk Theo Mean. The following window appears. Make a reference to B132, where a previously created at-risk compound function has been created. Click OK to exit. Cell B136 should now contain the following function. Equals risk theo mean, open parenthesis, B132, close parenthesis. At-risk statistic functions that return a desired statistic on a simulation input distribution have the identifier theo in the function name. For example, this function, risk theo mean, B132, returns the mean of the probability distribution in the cell B132, the compound function we have previously created. This is the first moment. Note that the theo functions do not require a simulation to provide the results. They return the exact, or theoretical, hence the name, statistics of the probability distribution. On cell B137, write the following function. Equals risk theo std dev, open parenthesis, B132, close parenthesis. It displays the theoretical standard deviation statistic of the compound distribution on cell B132. This is the second moment. On cell B138, write the following function. Equals risk theo skewness, open parenthesis, B132, close parenthesis. It displays the theoretical skewness or asymmetric coefficient statistic of the compound distribution on cell B132. This is the third moment. On cell B139, write the following function. Equals risk theo kurtosis, open parenthesis, B132, close parenthesis. It displays the theoretical kurtosis statistic of the compound distribution on cell B132. This is the fourth moment. With the 4 moments calculated, we now proceed to build a Johnson moments distribution. On cell B135, click on the Define Distributions icon and select the Johnson moments distribution out of the Continuous tab. The following window appears for this distribution. By clicking on the Parameters Standard Line, click on the icon to specify Excel references option, the following small window appears. By holding down the Control key while selecting cells, select the range B136 through B139. When finished, click on the upper right-hand side icon of this small window to return to the newly created Johnson moments distribution. Click OK to finish. The distribution you just created may have the following function: equals risk Johnson moments, open parenthesis, B136, B137, B138, B139, close parenthesis. This distribution pretty much replicates the compound distribution we had previously created. This methodology can be used whenever you have a small data set of points, starting from 5 to up to 30 or 40, where enough samples can give you room to calculate the 4 moments of your distribution.